Good afternoon, my YouTube viewers. In this video, what we're going to do is we're going to go over a series of questions, practice problems, using the t-distribution. Now, the t-distribution is similar to the normal distribution, with the exception that it has thickened tails. So we'll go through the first question. Is a sample of 12 students had an average test score of from 75 with a standard deviation of 5. The population mean score is known to be 75. Is the sample mean significantly different from the population mean at the 0.05 significance level? And we're going to perform a one sample test. So if your significance level is 0.05, then we're going to go ahead and make a program in Python to answer this question. And in order to make the program in Python, what we have to do is we have to import two libraries. So the first library that we're going to import is scipy, which is Python's scientific library. So from scipy, we're going to import stats. And stats is a statistical module within scipy. We're also going to import random, and that's an inbuilt module in Python. So that comes prepackaged with Python whenever you install Python on your machine. So you don't have to import that. You don't have to install that. That's installed when you import Python. So what we're going to do is we're going to set up our sample statistics. So sample mean is 75. Sample standard deviation is 5. And the N is your sample size is 12. So we're going to set up a grade array. So a grade array is going to be an empty list for grade in range n, and n is 12. Random number equals random.randint bracket 70, 80. So that means you're going to create a random integer from 70 to 80. Grade array dot append random number. So what that means is the for loop is going to iterate through the loop 12 times because n is 12. And then you're going to get 12 random numbers or random integers from 70 to 80. And you're going to append those random integers to the array or to the list. And then we're going to print the grade array. So now what we're going to do is we're going to set up our population mean equals 75. So your sample mean is 75 and your population mean is 75. Now we calculate the t-statistic and the p-value. So t-statistic comes with a t-distribution. So a t-stat, p-value equals stats.t-test underscore one sample, brackets, A equals grade array, pop mean equals population mean. So A is your grade array that has 12 elements in it because the for loop has iterated 12 times. And the population mean is 75 because it's already been established. So we're going to print the results of your t-statistic and your p-value. And we're going to determine if we reject the null hypothesis. So your null hypothesis is the sample mean is not significantly different from the population mean. And your null hypothesis will be accepted if your p-value is greater than 0.05. And then the thing is that your alpha is 0.05. And so If the p-value is greater than alpha, then you will fail to reject the null hypothesis. The sample mean is not significantly different from the population mean. If the p-value is less than the alpha or less than 0.05, you're going to reject the null hypothesis and say the sample mean is significantly different from the population mean. So that the null hypothesis, when you accept the null hypothesis or you fail to reject the null hypothesis, that's your null hypothesis. And then when you reject the null hypothesis, you have to go with the alternate hypothesis. So if it's greater than 0.05, you accept the null hypothesis. If it's less than 0.05, you reject the null hypothesis and accept the alternate hypothesis. So now we've printed off our data. So we've got our list of 12 scores. You've got a t-score of 0.3774. You've got a p-value of 0.7131. So you're going to fail to reject the null hypothesis. The sample mean is not significantly different from the population mean. One thing that you could do So that's one thing that we could do, see what the mean of the great array is, because it's all fine and nice to say that we're going to accept the null hypothesis, but it's important to know what the mean of the great array is. So we'll see if we can get it to work. So the mean of the great array is, and that didn't work. See if I can get it to work again. I hope it'll work this time. I thought to myself, oh wow, it hasn't gone into error. Fantastic news. So it's gone into error. Let's see why it's gone into error. Mean is not defined, that's why. So in order to get, well, one way I can do it is try this. Try that. See if we can get it to work this way. It says this object has no mean. So I'm going to give this a try. I'm trying not to import any more libraries. I'm trying to do it without importing a library. So it worked. You put the sum of great array divided through the length of great array, because that's 12. So the mean of great array is 73.91, and the population mean is 75. And so since they just say that it's the alpha, the p-value is still greater than the alpha, so it's going to accept it. So we've got the mean of the great array is 73.191, and the mean of the population is 75. So it's only 1 point between the two means, and so the null hypothesis has been accepted. But see, I wouldn't even do this. I wouldn't even say, it says the population mean, it says sample mean is 75. I wouldn't even say sample mean as 75. But it doesn't have the sample mean in there, so that doesn't matter. So that concludes this video. I'm going to do it says I've got a refined version of the code above. I don't know why I refined it. So that's like, this code is like to do a Pythonized for loop. So if you don't want to do a regular for loop, you can do a Pythonized for loop, a Pythonic for loop. So instead of putting the for loop, which is probably what I would do, you can say random.randint bracket 6, 80 for underscore in range n. And that's a Pythonic for loop. And all of the code in that is the same as well. So that concludes this video. I had originally wanted to put all of the questions in one video, but I've taken a lot of time with this one question. So I suppose I will break it down into separate videos. So thank you for watching this video. We did actually do a bit of troubleshooting in the video, which was good, and you did a bit of hypothesis testing, which was good. And so the next video is going to be about a researcher, so I hope that you decide to watch it.